So I hope you're able to see the screen. So 9.2, we discussed about verifying whether the given equation satisfies the differential equation, right? So in 9.3, what we are supposed to do is we need to form the differential equations. Okay, so we need to form the differential equations for the given condition or given curve. That is all this exercise is about. Okay, so let me explain what it is. One minute. Forming differential equation for a given curve. Okay. So in this exercise, what they will do is they'll give you a curve and we need to form the differential equation for it. For example, form differential equation for the curve x square by a square plus y square by b square is equal to 1. Or I'll make it even simpler. It is x square plus y square is equal to a square. Okay. So when I say forming a differential equation, this is a solution of some differential equation. Okay. So is this a general solution or a particular solution?
General.
It's, why are you saying it's a general?
Because it doesn't have a value, it's a standard equation.
Given a constant.
It has an arbitrary constant. Means the value of the equation will change as you keep changing the value of a. Right? It's a general equation. Because how many arbitrary constants does it have?
One.
One arbitrary constant. So remember, the number of arbitrary constants present in the question is equal to the number of times we need to differentiate. Okay. So remember, number of arbitrary constants is equal to number of times we need to differentiate. So if that is the case, then when you differentiate this implicit function once, what do you get? You get 2x plus 2y y dash is equal to derivative of a square is 0. It's a constant, but it's some arbitrary constant, right? So it is going to be 0. So 2 and 2 will get cancelled, which implies x is equal to minus y dash, which implies y dash is equal to minus x divided by y. Right? What did we do? We wrote the differential equation. dy by dx is equal to minus x by y. This kind of an equation we have seen in applications of derivatives itself when we solve problems based on tangents and normals. Do you remember? So according to applications of derivatives, what did we find? What have we found here? This is slope of
tangent.
It is a slope of the tangent that we have found. Okay. So in the case whenever this kind of an equation is given, when you differentiate and find dy by dx, you're actually finding the slope of the tangent. But in this context, in this chapter's context, what did we find? We found the required differential equation. So the required differential equation for x square plus y square is equal to a square is given as y dash is equal to minus x divided by y. Okay, so this is where you need to stop it. So there is the required differential equation. Shall we do one more problem? this. So what form the equation? We need to check arbitrary constant, right? So how many other? We have arbitrary constant. So always take constant to be 1. Then dy by dx d square y by dx square will be equal to 0. So this would be the required differential equation. Did you understand why I differentiated twice? Why is no one speaking?
Second order derivative test.
So there are two arbitrary
Not
constants.
second. It's because there are 2 arbitrary constants. That's the only thing. In this context, we are not going to do any derivative test. Number of arbitrary constant is equal to number of times we are. Okay. Similarly, let's take an example number 3. Somebody is voice. Form the differential equation for the curve x square by a square plus y square by b square is equal to 1. So what is this?
Ellipse.
The ellipse, right? We need to. So how many arbitrary constants? Look for it. 2. So we need to differentiate it twice. So differentiating on both sides, what do we get? Let this be equation number 1. When you differentiate on both sides, you get 2x divided by a square plus 2y into y dash divided by b square is equal to 0. Yes or no?
Yes, sir.
Yeah. So 2x by a square plus 2y into y dash divided by b square is 0. So we need to again differentiate it. When you differentiate it again, 2 divided by a square plus, what do you get? 2 divided by b square into y into y double dash plus y dash into y dash. I've applied UV rule. This will be equal to 0. So 2 by a square plus 2 by b square into y double dash plus y dash square is equal to this be equation number 3. So what we need to do here is from 2, y dash is how much? From 2, what is y dash?
XB square
Or
by
what
a
we
square y.
or wait, I'll tell you a simpler method. From 2, see our work. The reason why we are differentiating it twice is because we need to eliminate the arbitrary constant. That is our whole objective. Okay. So when that should happen, from 2, can I write it like this? 2 divided by b square is equal to, or I can take 2 divided by a square itself. So 2 divided by a square will be equal to 2 into y by dash divided by b square into 1 by x. Did you understand what I did?
Yes, sir.
Sir, minus will it
The
become
minus, sir.
Yeah, minus is there. Yeah. Okay. So let me call this as star. So in the place of 2 divided by a square, what can I do? Minus 2y y dash divided by b square into 1 by x plus 2 divided by b square into y double dash plus y dash square will be equal to 0. So b square gets cancelled. What is that you're left out with? 2 is also going to get cancelled. Y dash divided by x is equal to y dash plus y dash square. So when you rearrange it, this is one of the ways in which you can write the differential equation. Did you understand?
Yes, sir.
Y double dash. So this is what we need to do in this particular exercise. Okay. So to my knowledge, they have actually deleted this from your exercise, from your syllabus for this year. But this is the outline. The reason I've explained this is because whenever you're forming a differential equation, you need to understand how many arbitrary constants are going to come. So this exercise, I've explained the outline part. What you need to do is you can try all these problems irrespective of the syllabus, so that you will have good practice of differentiation as well as understanding of how to solve the next exercises. Okay, so this part I'm leaving it to you, this exercise. If there are any doubts, you can let me know. Now I'm going to the next exercise, that is methods of solving the first order and first degree differential equations. So in this chapter, we are going to concentrate only on the first order and first degree differential equations. So you know what is first order? Dy by dx is first order. First degree is any power, any order raised to the power of 1. Right? So you know these 2 points. Now what we are going to do is we are going to find the solutions for it. The first method is called as variables and separables method. Okay. So differential equations with variables separable. So the meaning of this is you can separate the variables and write it. That is the meaning. So till now, what did we do? Till the third exercise, though the name of the chapter is differential equation, what exactly were we doing? If a function is given to us, depending on the number of arbitrary constants that are present on it, we were differentiating and trying to find the differential equation. Going forward, what will happen is, if a differential equation is given to you, then if they're asking you to find what is a function for which this differential equation is actually coming out, then we need to go in the reverse process. I told you already. So when a function is given to you, if you want a differential equation, what are we supposed to do? Differentiate. Whereas a differential equation is given to you and the function is asked, you're going to
Integrate.
integrate. Okay, so going forward, we are going to do integration. In that, the most important method is this variable and separable. This is the basic method that is there. Okay, so let me explain how do you solve the problem using variable separable. So write down the heading, differential equation with variables separable. Okay, I will take an example from what we have solved today. Okay, see, observe. If you look at this equation, dy by dx to minus x divided by y. That's there, right? So dy by dx is minus x by y. Let's say dy by dx is equal to minus x by y is the differential equation they have given. Okay. Now what is our work? We need to find the function from which this differential equation is actually coming. For that, observe the method to be followed for this variable and separable is each side of the equation should have variables of x on one side and variables of y on the other side. For example, in this problem, what I can do is I can take y to the other side, means I can write it as y dy is equal to, I can take dx to the other side. Can I write it as minus x dx? Are you guys able to understand this point? Means
Yes,
if you
sir.
observe, left hand side is completely dependent on y and the right hand side is completely dependent on x. So what we are going to do is differentiate, integrate both sides, integrating on both sides, that's it. No with respect to above. So when you integrate on both sides, what do you get? Integral of y dy will be equal to integral of minus x dx. Okay. So integral of y dy is how much? Y square divided by 2 is equal to minus x square divided by 2 plus, since you are doing indefinite integration will require a constant. Are you guys able to understand this point? So if I take the constant, for example, I'm leaving it as c itself, then I'm bringing this minus x square by 2 this side. It becomes x square by 2 plus y square by 2 is equal to c. Accepted? So this is x square plus y square is equal to 2c. What does this actually represent? This still represents center. Tell me one thing. Are you guys clear till this point? This step. Did you understand how I formed this equation? X square plus y square is equal to 2c.
Yes, sir.
Now see. So the first question that we took is x square plus y square is equal to a square. Means in this context, what is happening? That a square is what is given as 2c. Right? X square plus y square, forget about a square. X square plus y square is equal to some constant. Itself represents that it is the equation of a cell with center as origin. And that is what we have got here. So now I hope you are able to understand how these two exercises are related. Right? And mainly these kind of integration we are going to do only for first order and the first degree differential equations. Please make a note of it.
Sir,
Yeah, tell me.
sir, is this also a general equation solution, general solution?
Yeah, it is because it's a general solution. Because you have 2c, no, we don't know what is the value of c. It's a general solution.
Okay, sir.
Okay, yeah. Okay, if you're clear with this, shall I proceed to the next problem? We can start the exercise problems. Shall I proceed?
Yes, sir.
Okay. This is 9.4, right? So find the general solution of the differential equation. Dy by dx is equal to x plus 1 divided by 2 minus y. See, generally it is in this form. When I write like this, y is equal to f of x, what is the meaning of this? How do you understand? If I give you a statement like y is equal to f of x, what is your understanding? You're trying to say that the variable y is dependent on x, right? If I give you a question like f of y, what will you say? You will say the variable y is variable x is dependent on y. Am I right? So here, if you observe, dy by dx is neither completely a function of x nor completely a function of y, because right hand side, what is it you have? You have both x and y present in this dy by x capital F. Okay. So it is a function of x and y. Whenever you see this kind of an expression, we need to apply the variable separable method. So according to variable separable, what can I do? So given is dy by dx is equal to x plus 1 divided by 2 minus y. So 2 minus y into dy will be equal to x plus 1 into dx. Accepted? So what is it we need to do? We need to integrate on both sides. So when you integrate on both sides, you get 2y minus y square by 2 is equal to x square by 2 plus x plus c. I hope it is clear. So x square by 2, bringing y square by 2 to the other side, it becomes y square by 2 plus x plus 2y plus c is equal to 0. So take multiplying with 2 on both the sides, you get x square plus y square plus 2x plus 4y plus 2c is equal to 0. So what does this represent?
Circle.
Circle with what? It represents a circle with center at minus 1
It
comma
is minus 2.
Sir, minus 4y.
minus 4y, sorry, minus 2y minus 4y. Then center will be minus 1 comma plus 2. I hope you are able to understand, right? So this is also a general solution because you have 2c, which is an arbitrary constant. It's not a fixed value.
Sir,
Sir, can you
Yeah,
explain,
tell me.
sir?
so why didn't you
Which
add
one?
a constant at the LHS, sir?
You can do it that side also.
Is there anything specific? Because why is there you're not
Not,
supposed to add or something
nothing,
like that?
nothing like that. Because see, that c value I don't know, no. So if you want me to add plus x, I'm leaving. Then x to the other side, y square plus x minus 2y minus c is equal to 0 is what I'm going to get. Whether it is going to be plus c or minus c, I'm not bothered about it because it's not a fixed value. I don't know what is the value of it unless certain conditions are given to me. Now what I will do is I will take this minus here, but still it's a constant. You're able to understand this point. So it has nothing to do with whether you're taking it on left hand side or right hand side. It is up to you. So what we need to do is you need to take the y variables on one side, x variables on the other side, as simple as that. Okay. So as we progress, you guys will understand what I'm doing. Shall I move on to the next problem? Again, see. Find the general solution of the differentiation dy by dx plus y square by 1 plus x square. So you have to first look whether x terms and y terms are separable. Are they? Can I completely bring y terms to one side?
No.
I can bring it by taking it as 1 plus y square. Dy divided by 1 plus y square is equal to dx divided by 1 plus x square. So I brought it, right? Now integrating on both sides. Just give me a minute. Integrate on both sides. Okay, when you integrate on both sides, what happens is, what is integral of 1 by 1 plus y square?
Tan inverse y.
Yes, tan inverse y is equal to tan inverse x plus c. Okay, so what will be the required answer? Tan inverse x minus tan inverse y plus some constant is equal to 0. That constant can either be c, k, anything. So the meaning of it is, when you differentiate this expression, you will get back this thing. You can do a test and see. We can check and see. So when you differentiate tan inverse x, what do you get? 1 by 1 plus x square. When you differentiate tan inverse y, you get 1 by 1 plus y square into y dash. Plus, when you differentiate a constant, it will be 0. So y dash will be equal to 1 plus y square divided by 1 plus x square, which is a given question to us. Okay, you can do this as a testing process. Can I go a little fast?
Yes, sir.
So listen, here the question is particular solution. Whenever there is a question which is based on particular solution, they'll give you a condition. Okay, when they give you a condition, you will be able to find the particular solution. Now observe, the solution is dy by dx is equal to minus 4x y square. You need to verify whether the right hand side, is there a possibility for you to separate y and x separately? In this question, is there a possibility?
Yes, sir.
So what can we do? dy should be
Y
combined
square.
with y square, and minus 4x should be combined with dx. Right? We are able to do this. See, the reason I'm telling you again and again is because when you do the miscellaneous problems, you will face difficulty. So first, you do this preliminary check and then proceed. So when you integrate on both sides, what do you get? Integral of 1 by y square is minus 1 by y. Is minus 1 by y is equal to minus 4 into integral of x is x square by 2. You can write some constant plus c. So what is it you're going to get? You will have 2x square minus 1 by y is equal to c. So this will be the general solution. But what have they told? They don't need the general solution. They need the particular solution. So for that, what have they given? When x is 0, y is 1, means the coordinates of the given point is 0, 1. When you substitute 0, 1 in this, what do you get? 2 into 0 minus 1 is equal to c, which implies c is minus 1. So what will be the required particular solution? So the particular solution that is required is 2x square minus 1 by y is equal to minus 1. Okay. I hope I'm clear.
Yes, sir.
Okay. We shall move on to the next question. Find the equation of the curve passing through the point 1, 1. So when they say equation of the curve in this scenario passing through 1, 1, even before you complete the question, tell me, will you get a general solution or particular solution?
Particular.
You will get particular because because the condition is given. Whose differential equation is x into dy is equal to 2x square plus 1 into dx. Right. So the solution here is very simple. X into dy is given as 2x square plus 1 into dx. What are we supposed to do? Dy will be equal to 2x square plus 1 divided by x into dx. Right. So we can write it like this. Dy is equal to 2x plus 1 by x into dx. Now integrating on both sides, what do you get? Y will be equal to 2x square by 2 plus ln x. Okay. Max, we write it as log x only. So it is log x. Plus, don't forget the constant c. Okay. So y is equal to 2x square by 2. This and this will get cancelled. So y is equal to x square plus log x plus c will be the general solution. But what is given? Given curve passes through 1, 1. So substitute 1, 1. So 1 will be equal to 1 square plus log 1 plus c. 1 square and 1 will get cancelled. Log 1 is 0, which implies c is 0. So what will be the required particular solution? Y square. Sorry.
Why, sir?
Yeah, y. Y is equal to x square plus log x. So this is the required general solution. Sorry, particular solution. Okay. I hope you all are doing along with me. Next. Find the equation of the curve passing through the point minus 2, 3, given that the slope of the tangent to the curve at any point x, y is 2x by y square. So slope of the tangent according to applications of derivatives is dy by dx is equal to, okay, which implies dy square dy is equal to 2x dx. So integrate on both sides. Then it will be y cube by 3 is equal to x square plus c. So this is the general solution. Curve passes through what point? Minus 2, 3. So substituting minus 2, 3 here, you will have 27 by 3 is equal to 4 plus c. So this will go 9 times, which implies c is 5. So what will be the required solution? Y cube by 3 is equal to x square plus 5 is the required particular solution. I hope it is clear.
Yes, sir.
Okay. So once you complete this, I'm making a small change to the question. Instead of giving slope of tangent at the normal, then see how you are going to. Okay. First copy this, then use the concept of slope of normal and tell me what will be the equation that you are getting. To be honest, even I don't know the answer. Let's do and verify the common answer. Okay, same thing. We need to find the particular solution. Now tell me, what is the slope of normal?
minus 1 by y dash.
Or I can write it as minus dx by dy. Right, this will be equal to 2x divided by y square. My 2x divided by y square. So minus dx by 2x is equal to dy by y square. So we need to integrate on both the sides. What do you get? Minus 1 by 2 log x is equal to minus 1 by y plus c. Right? So which implies, so let's say this is the general solution. What is the point they have given? Minus 2, 3. Yeah, minus 2, 3. So what will be the answer?
No solution.
No solution is possible. Why? Because you are trying to define log of minus 2. So there is no solution that is possible where this curve can pass through minus 2, 3. Maybe had the question been 2, 3, we could have solved it. But I hope you understood. Whenever there is a question given, you need to read it carefully. If they want to twist it, they might say slope of normal or slope of tangent. You need to read it carefully. Okay, so this is the main point I wanted to discuss. I'm moving on to the next question.
Sir, or doubt, sir.
Yeah, tell me.
Sir, usually when you integrate log mod x, then is one, no? So when x is equal to minus 2, shouldn't you take log 2?
Say log of mod x means, what is it you're trying to say is you need to have a positive value here. Generally, if you look at the function, how log x is defined, no, there is nothing like log mod x. If you take the function is still log x only, when the function is defined, you're trying to ensure that the value of x is greater than 0. That is what you're going to do.
Oh, okay.
See, you're trying to define the domain. When you're trying to define the domain itself, it says it should be x should be greater than 0. Okay?
Okay.
So we write mod x in the case of integration for us to have in mind that you need to have a positive value. That is the meaning. Don't take the literal meaning of mod x.
Okay, sir.
Okay?
Yes, sir. Yes, sir.
These kind of statement problems are so these kind of statement problems are not there. Okay, these problems are not there. The only thing that is there is they'll give you the equations here. Let's start the exercise. Can we go a little fast? I feel I'm very slow. Can I go a little fast?
Yes, sir.
So you also can try with me parallelly. You can only verify the steps. Okay. So solution dy by dx is equal to 1 minus cos x divided by 1 plus cos x. So what was dy by dx is equal to 1 minus cos x is 2 sin square x by 2 divided by 1 plus cos x is 2 cos square x by 2. 2 and 2 will get cancelled. It is tan square x by 2. So right hand side is completely a function of x. So dy will be equal to tan square x by 2 times dx. So dy will be equal to, we cannot solve tan square x by 2 directly. We'll have secant square x by 2 minus 1 times dx. So dy will be equal to integral of secant square is, so integrate on both sides. Y will be equal to integral of secant square x by 2 is tan x by 2 divided by half minus x, and you have a constant c. So y will be equal to 2 tan x by 2 minus x plus c. If anyone is having textbook with you, please verify the solution. So y is equal to 2 tan x by 2 minus x plus c.
Yes, sir.
Okay. Okay, this is the required general solution. So moving on to the next question. So dy by dx is equal to root of 4 minus y square. Solution. Dy by root of 4 minus y square is equal to dx. So what will be the required answer? Integrate on both sides. 1 by root of a square minus x square.
Sin inverse x by a.
Sin inverse y by a is equal to x plus c. Y by, here a is how much?
2.
That's right. Sin inverse y by 2 is equal to x plus c. That will be the required answer. So let's go to the third question. So third one is dy by dx plus y is equal to 1. So here, what will we do? What should we do? Solution is dy by dx is equal to 1 minus y. Now it is easy for us to separate the variables. So dy divided by 1 minus y is equal to dx. So integrating on log 1 minus y is equal to x plus c. Correct? There is a
No, sir.
mistake.
Minus
There
log.
is, yes, by minus 1 because the coefficient of y is minus 1. So you will have x plus log of 1 minus y plus c is equal to 0. So x plus log of 1 minus y plus c is equal to 0. So just verify the final answer. If it is not given in this kind of form, let me know.
So it's given us 1 plus a e power minus x.
Okay, they have brought the exponential function, right? Okay. Then see, I'll tell you what they would have done is, See, in few problems, what we can do is, you can ask me how will we know when to apply what? If you leave it like this also, it is right. I'm not saying it is wrong. As I told you, these kind of problems they will have multiple answers in their hand, which gives the same expression. So if you leave with this also, it is right. If at all the question comes in MCQ and you are not able to find this option and you are able to see exponential options in it, then you need to do certain rearrangements. What we need to do is observe. The idea is, on integrating, sometimes you have logarithmic function getting generated. On integrating, if log function is an output, then take the constant as log c. Take the constant as log c. If at all you do this, then what will happen? So minus log of 1 minus y will be equal to x plus log c. Can I write it like this? Are you guys able to understand this? So what I will do is, x will be equal to minus log of 1 minus y minus log c. Accepted? So this will be, can I write it as minus x is equal to log of c into 1 minus y? Correct? Can I write it as log of c into 1 minus y? Which implies c into 1 minus y will be equal to e power minus x. Right? So 1 minus to 1 by c power x, which implies 1 minus power minus. You can write it as some other constant. Let's say it is k. Then y will be equal to 1 minus k e power minus x. So this will be the required. So as function where you are able to separate the dependent and the independent variable. If you look at this, it is of the form y is equal to f of x. But I hope you are able to understand that they both mean the same. Right?
Sir, can you explain it again, sir?
Which one? From where?
Second part, sir. I mean the
I'm
idea
saying,
of
whenever you have this logarithmic function, you need to take the con.
Sir, your voice is breaking, sir. It is not audible.
Yes, sir.
Is it better now?
Yes, sir.
Yes, sir.
Yeah. 1 minute, wait. So whenever on integrating you have logarithmic function. See, that too most importantly, when one function is logarithm and the other is some other variable, If at all expect you to express it in the form of explicit function, then this is what is an explicit function. Y is equal to f of x format. Okay. If you want to do that, then what you can do is, instead of taking the constant as c, you're allowed to take it as log c also. So once you take it as log c, you can do the necessary rearrangements like how I did. I took the constant as log c. You see, instead of c, I took it as log c. Then what I did is, I rearranged the equation and then got the final expression in the form y is equal to 1 minus k into e power minus x. Have they given it as 1 minus k into e power minus x or 1 plus k into e power minus x?
Plus,
Plus means what they have done is they have taken minus 1 by c as k. Okay. But this is also right. So how to verify this is right or wrong is, if you differentiate the general solution that you have obtained, you should get back the question. Okay. So as of now, what you can do is have this idea in your mind. Wherever there are logarithmic functions that are coming out, when you integrate the differential equation after doing variable separables, then you can take the constant as log c. If you do few more problems, you will understand. Okay. So please wait for it. For example, you take this question: secant square x into tan y dx plus secant square y into tan x dy is equal to 0. So how to solve this? So you can write it as secant square x tan y dy is equal to minus secant square y tan x dy. Now what we will do is separate the y terms and x terms. So secant square x divided by tan x into dx is equal to minus secant square y divided by tan y into dy. So secant square x by tan x, what is it you are going to get? Okay. Now you can multiply with 2 on both the sides. So what are you going to get? Dx divided by, so what is it? Dx divided by sine 2x is equal to dy sine 2x. So 1 by sine 2x can be taken as cosecant 2x. Is there any doubt till this till? I'll solve this problem using, I'll solve it using another method also. Now you have got this. So what is the integral of cosecant?
log cosecant x minus cot x plus.
So log of cosecant 2x minus cot 2x, in this case you will have by 2, is equal to, what is it you are going to get? So since you are getting log, what can we think of? You can take the constant also as,
Log.
Log C.
you can take it as, you can take the constant as log c. When you do this, what you will get is, so cosecant 2x minus cot 2x, when you try to take LCM and solve, what is it you are going to get? Can you solve and tell me? So cosecant 2x, write it as 1 by sine 2x. Cot 2x, write it as cos 2x by sine 2x. Why is there no response today? You're not able to understand, is it tough?
No, sir. No, sir. Doing it.
Then, okay. Little low on energies today. Generally, people ask so many questions. Okay, cosecant 2x minus cot 2x is going to be what? So it will be 1 minus cos 2x divided by sin 2x. Am I right?
Yes, sir.
Yes, sir.
Yes, sir.
Sin 2x. So 1 minus cos 2x is going to be 2 sin square x divided by sin 2x is going to be 2 sin x cos x. So 2 and 2 will get cancelled. Sin and sin are gone. You will be left out with tan x.
Tan
Right. Similarly, here what will you be left out with? Tan y.
Tan y.
And y.
So log tan x will be equal to minus log tan y plus log c. Can I write it like this? So log tan y, I'm writing it as log tan x minus log c. Accepted? I'll tell you why I wrote it like that. So log tan y is equal to log tan x minus log c. The reason I wrote it like that is because I wanted to write it as an explicit function. Because in your textbook, if you see, every answer will be given as y is equal to something, y is equal to something. So I need only y on the left hand side, all other x and constant terms on the right hand side. If I do this, then what will we get? Log of tan x divided by c is equal to log tan y. Then what can we say? Tan y is equal to tan x by c. So this will be the required general solution.
Sir, it's log c minus log tan x.
Where is it?
It's
Log
minus
tan y
log
is equal to
tan
Oh,
y.
minus log tan,
x.
minus log tan x, right? Yeah. Log c
So it'll be
minus.
tan x into tan y is equal
Yeah.
to
Then
c.
you will. That's right. That's right. Log c minus log tan x. So you will get c divided by tan x, correct? So c divided by tan x. Then you will have tan x into tan y is equal to constant. Is that the answer they have given?
Yes, sir.
Okay. So tan x into tan y is equal to constant. This is the required general solution. So what we did is we tried to write in the form of sin 2x and then solve. Right? Is there any other way you can solve this problem? The alternate method is we had one of the steps like the secant square y divided by tan y with a minus sign into dy is equal to secant square x divided by tan x into dx. Correct? If you observe, if I take tan y as t, the numerator is derivative of t. So secant square y divided by tan y. So what will you get? Log of minus log of tan y is equal to log tan x plus log c. You can solve it in this way also. Try to rearrange and solve the problem. You will still get the same answer. Okay.
Yes, sir.
Moving on to the next problem. So dy by dx will be equal to e power x minus e power minus x divided by e power x plus e power minus x. Okay. Just rearrange the equation. If you observe the right hand side, it is a complete function of x. So dy will be equal to e power x minus e power minus x divided by e power x plus e power minus x times dx. Integrate on both the sides. Y will be equal to, what do you get here? If you take the denominator as
sir.
numerator is a derivative of t. So you will get log of denominator e power x plus e power minus x plus you can take it as log c. So what will you get? Log of c into e power x plus e power minus x is equal to y. So c into e power x plus e power minus x is equal to e power y. You can write it like this. So this is one of the answers. You can actually leave with this also. So this is also right answer because We have written it in the form of y is equal to f of x. You can leave it with this, or you can write it in this form. This is going to be in the form of, it is going to be in the form of an implicit function. Okay.
Sir, I have a
So,
doubt. So how will we integrate that e power x minus e?
this one. Huh?
Yes, sir.
Okay. So what I did is I took the denominator as t, e power x plus e power minus x. If you take it as t, if you differentiate on both the sides, e power x minus e power minus x dx will be dt. So numerator is dt, denominator is t, answer will be log t. T is this thing substituted back.
Okay, sir.
I hope you understood.
Yes, sir.
Okay. So moving on to the next question. You people do this, tell me how to do. Dy by 1 plus y square is equal to 1 plus x square times x. Solve this, tell me what is the answer.
Tan inverse y equal to x plus x cube by 3 plus
Tan inverse x y,
y, sir.
tan inverse y is equal to, how much is it? X plus x cube by 3.
See,
You can either leave it like this or you can write it as y is equal to tan of that thing. It's better to leave it in the form of inverse trigonometry. This will be the equation. Next one. Y log y dx is equal to x dy. So you can write it like this. Dx divided by x is equal to dy divided by y log. Now, see, left hand side is easy. Integrating, you get log x. But how will you deal right hand side?
Log y as t, sir.
You take log y as t. So for right hand side, you take log y is equal to t, then 1 by y into dy will be equal to dt. Means dy by y can be taken as dt and log y will be t. So what will you get?
Log of
log y.
Plus you can take it as log c. So try to have the log of log y on the left hand side. This will be equal to minus log x plus log c. So log of c by x is this thing, that is log of log y. Right. So log y will be equal to c by x, which implies c is equal to x log y. Or if you want to write y in terms of, so what you can do is, if you want only y, see, I'm not saying this is wrong, this is right. If you want only y in terms of x, then we can do some more rearrangement. C by x is log y. So from this, the alternate way to write is y is equal to e power c by x. This is also another solution. This is also right, or this is also right. Both mean the same. I'm not sure how the answer is given at the back.
Sir, it's e power cx it's given.
E power cx.
Yes, sir.
Yes, sir.
Right. No sign mistake, right? Y log y is equal
Sir,
to
it
x.
is log x plus log c, right?
Where no? Well, log x plus log c.
Yes.
No. See, this is there, no? log y is there. Oh yeah. So it will be log x minus log c. So it will be log of x by c is this thing. Then log y will be equal to x by c, which implies x is equal to c log y. This is one of the options. Or what we can do is y will be equal to e power x by c. This is another
Sir,
option.
there is no need of
Yeah, tell me.
minus log c, sir. Already
You
the
can
RSS is plus.
let us see log of log y. I took the log c to the other side now. According to what I have considered, I took log c to the other side now. See, you are trying to say the answer given is y is equal to e power cx. But the c he has the c that is
Oh,
considered
okay,
in
sir.
your
Okay.
textbook and my c are not the same
Okay.
because it's a generic value.
We
Or
can take 1 by c as a constant.
you can take y is equal to e power kx, where the k is nothing but what 1 by c. I hope you people are getting confused with this constant. No, if I'm not wrong. Do you want more clarity on that? I personally feel you are getting confused with this constant. You
Yes,
just
sir.
give me a okay.
Yes, sir.
See, you have nothing because see, you have nothing to do with the C I'm taking and the one which is given in your textbook. Both the C doesn't mean the same because they are arbitrary constant. You don't know what is the value of it. It is just some value that we are taking. Maybe if you look at the NCERT solution somewhere, they might have taken this log C on the left hand side. If you do that, then you would have got log x into log C. So what I'm trying to say here is, see, you need not worry about where the constant is because someone asked me whether it is going to be right hand side or left hand side. It is not going to matter at all. So you can take it as log c on the left hand side. If you do that, then when the log c comes to the other side, I hope you understood this step. I'm using a blue color pen. Just confirm. I hope you understood this step, right?
Yes, sir.
Then
Yes,
what
sir.
I did is I took it as log x by c. Then I see log of something is equal to log of something. So I took the values inside the log to be equal. Log y is equal to x by c. Then I wrote x is equal to c into log y. If you leave it like this is also right. Maybe if you get this in MCQ and you see this as one of the options, you can mark it. Or if they give it in the form y is equal to f of x, then what we can do is log y. So from this step, what I'm getting is log y is equal to x by c. No, then y will be how much? From this step, if I write, y will be equal to e power x by c. Don't read it as x by c, read it as x by some constant. And remember, 1 by constant is also a constant. That 1 by c, you can call it as some other variable k and you can still rearrange the equation. So you can write it as y is equal to e power kx. Where the k that I have taken here and the c that they have taken in the textbook are the same. Okay, where that value of k or c will get revealed is when you try to write the particular solution. Your particular solution will be exactly the same for everyone, but general solution might vary only in terms of constant, not in terms of the expression. What I'm trying to say is, if you leave the answer like this, it is right, or if you leave it like this, also it is right. Because it is textbook, they are given only one method, but I'm giving you 3 alternatives. I hope I could clear some part of your doubt.
Yes, sir.
Right? Yeah. Shall we proceed to the next one? Now see, you people try to solve this. Dy minus dy divided by y power 5 is equal to dx divided by x power 5. So what is the integration answer for this? So what we can do is 1 by 4 right. I'm bringing this to the left hand side. X power minus 4 plus y power minus 4, the whole divided by 4 is c.
Sir, can you explain the second step, sir?
This one,
Yes, sir.
I integrated that. So y power minus 5 dy with a minus sign is minus x power n plus 1 by n plus 1.
Okay, sir.
Okay. Moving on to the next one. So dy by dx is equal to sine inverse x dx. So for this, what are we supposed to do? Y is equal to integral of sine inverse x dx. What are we supposed to do?
So y is equal to 1
By
by root
parts.
of 1 minus.
1 by root of 1 minus x square is derivative of sine inverse x. It's not integral.
Take x as sine.
Integration by parts.
You have to do integration by parts. Sine inverse x dx. So I let. Okay. So y will be equal to how much is it? First function into what is the second function, guys?
dx.
Sine inverse x into 1. So first function is sine inverse x, second function is algebraic, that is 1. So first function into integral of second function, that is x minus integral of derivative of first function 1 by root of 1 minus x square into integral of second function, that is x dx. Okay. You will have a plus c. So x sine inverse x minus, how to get the integral of this? Multiply and divide with 2. Then what will happen? You will take 1 by root of, you will take 1 minus x square as t. Are you guys able to understand what I'm doing? Minus, okay, wait. Let me call this whole thing as I. So I will be equal to integral of 2x divided by root of 1 minus x square dx. So what are we supposed to do? Put 1 minus x square is equal to t, which implies minus 2x dx is equal to dt. So it will be integral of minus dt divided by root t. So what is integral of 1 by root t? Minus is already there. It is 2 root t. So what is it? Minus 2 root of t is 1 minus x square. So I is how much? Minus 2 into root of 1 minus x square. Hence, y will be how much? X into sine inverse x. You already have a minus here. This minus is getting multiplied with I has a minus in it. So it will become plus 2 into root of 1 minus x square plus c. So this will be the required answer.
Sir, in I will be there, denominator 2 will be coming. Sir.
2. Okay. 1 minute. Thank you. So if I take the 2, then it should be only root t, right? So you have 1 by 2. Here you will have a 2. This and this will get cancelled. You will have minus root of 1 minus x squared. Can you please check the answer if this is the one? Y is equal to x sin inverse x plus root of 1 minus x squared plus c.
Yes, sir.
Yes, sir.
The 2 is not there, no?
Not this, sir.
So we'll do one last problem for today. So I hope with respect to concept, there is no problem that is tough, right? We need to again recollect our integration basics, that's it. We'll do one last problem for today. The 10th one is e power x tan y into dx is equal to plus 1 minus e power x into secant square y dy is equal to 0, right? So how to proceed? E power x tan y dx is equal to minus secant square y into e power x. I'll do one thing. I've taken the minus. So minus secant square y into 1 minus e power x dy. Okay, we can push the minus inside. So tan y into e power x dx is equal to secant square y into e power x minus 1 dy. Correct? So we'll collect all the x terms on the left hand side. E power x by e power x minus 1 dx is equal to secant square y by tan y dy. So when you integrate on both sides, how to integrate the left hand side?
Denominator as t.
You take the denominator as t. For LHS, e power x minus 1 will be t, which implies e power x dx will be equal to dt. So when you do that, what will you get? You will get log t.
E power
So
x.
answer will be log of e power x minus 1 is equal to, what will you do here? For RHS,
Log
it's
tan
like
y.
the, yes, take tan y is equal to t, secant square y dy will be equal to dt. So it will be log tan y. Since both the sides you have log, it's advisable to take the constant as log c. Right. So log of e power x minus 1 minus log c is equal to log tan y. So how can I write it? Log of e power x minus 1 divided by c is equal to log tan y. Okay. Then what can we conclude from this? E power x minus 1 divided by c is equal to tan y. E power x minus 1 is c tan y. So one minute. We need y, right? I'm not sure how the answer is given. We can say y is equal to tan inverse of e power x minus 1 divided by c. Or you can write some k times e power x minus 1, where that k is 1 by c. Can you please check the answer and tell me how it is given?
Sir, they just multiplied the c, that's it. In the second last.
They took the c to the other side, that's it, right? So tan y is equal to, how did they give? Tan y is equal to?
So they took 1 by c as a constant, sir.
1 by c as a constant, right? So that's what I told you. It varies from problem to problem. This is also right. This is also right. So ultimately, you need to do only one thing. If you differentiate the final answer that you get, you should get back the question. That's it. But I will not suggest you to do for every problem. Once you start practicing more, you will get clarity on how to leave the answer. Okay. So there is one issue with this particular exercise. I hope it is clear till this step.
Yes, sir.
Okay. So the remaining problems I would like you guys to try. Okay, if you have any doubts, 11 to 14, we need to find a particular solution. So try to find it out. You can solve it as homework. And I'll clear. You can solve from 11 till the last problem. If I'm not wrong, you have 10 more problems left out. So you need not do these statement problems. These kind of statement problems are not needed. 15. 15 is 1 minute. No, 15 is fine. Yeah, you can do 15. 16, yes. 17, you can do. 18, you can do. 19, you need not. 20, you need not. 21, you need not. 22 also, you need not. Again, 23 you can do. So what are all the problems you need not do? 21, 22, 20, and 19. 19 to 22 you need not do. Remaining problems, do it as homework, and I'll clear your doubts in the next class. The next class we'll complete this chapter. And secondly, one important point, this week you will have integrals test. It was supposed to be held last week, but I forgot to announce. So this week for sure you will have integrals test on Sunday. Okay, it will be 1.5 hours test, 40 minutes. Okay, morning 10 to 11:30 a.m. Please make a note of it.
Sir, full chapter, thanks, sir.
Yes, sir, full done. Full done. So integrals, full chapter, including the deleted portions will not be asked. Okay, that will not be tested. Full chapter. Okay, so that's all for today. Just give me a minute.